In this case, we have another example of a converging lens, but the object is placed between the focal point of the lens and the lens itself. So our object in this case is located 8 centimeters from the lens, and the focal point is 20 centimeters from the lens. And the question is to determine the location of the image that's formed by this lens. So this is basically the same type of problem we did in the previous case. So the thin lens formula works. We have 1 over the object distance plus 1 over the image distance is equal to 1 over the focal length. Our object is located 8 centimeters from the lens. Our image distance is what we're trying to find, and the focal point is 20 centimeters. So 1 over the image distance is 1 over 20 minus 1 over 8. So if we put that into our calculator and we put in 1 divided by 20, we get 0.05. And then if we take 1 divided by 8, we get 0.125. So 1 over q is 0.05 minus 0.125. And we get a negative 0.075. So remember that we're not finished yet. In order to find our answer, we have to multiply both sides by q. So I can multiply the right side by q, the left side by q. Q's cancel, and I have 1 is equal to minus 0.075 q. And then I can divide both sides by 0.075, negative 0.075. So when I do that, I get 13, or negative 13.3 centimeters. So we're getting an image distance which is negative. So what does the negative sign mean? So the negative here means that our image is virtual, and it's on the same side as the object. The negative image distance is also going to tell us in this case that it's upright. But in order to maybe explore that a little further, we could find the magnification, and the magnification is negative the image distance over the object distance. So this is minus a negative 13.3 centimeters divided by 8 centimeters. The negative and the negative cancels. It becomes positive. 13.3 divided by 8 equals 1.66. So the magnification is greater than 1, which means that the image is larger than the object, and it's positive, which means that the image is upright. And that is true according to what we have in our picture.